Hi everyone. Um, I'm recording this video for my project, which I'm doing from Coursera on machine learning foundation for product managers, uh, module 6 core project. This is a peer graded assignment for which we are required to submit a short demo video where we are showing how we have done our project. So in this project, we are required to follow a modeling approach, build a model, evaluate a model, and interpret a model. So that's going to be our grading criteria. And the project is about a combined cycle power plant where we have four variables: temperature, ambient pressure, relative humidity, exhaust vacuum. These four variables will be used to predict the net hourly electrical energy output. And we have been given a data set, and these are some guidelines for the project that we need to follow. So I'll jump right into our data set to show how we have done this, right? The first thing that we have done here, we are required to do here is what is the machine learning approach that we'll be following. So in this case, since we have four variables and one output predictor variable, that is this column E, so we are going to use multiple linear regression, right? And what are the output metric to evaluate the performance? I'll be using the mean squared error and R square, which is the coefficient of determination to evaluate the performance of the model, determine which features we might want to use. So what we've done here is that in one model, what in one model we are using all the four features, and in another model we are not using one of the features, which is temperature, and seeing that which model performs better, right? So that is step three. Uh, the step four is split the data. So what I've done is I've gone a step ahead. Instead of just splitting the data into training and test set, I have split the data into three, like training set. I've also mentioned it here, training set, which has 60% of the data, validation set, which has 20% of the data, and test set, which has 20% of the data, right? So what we'll do is on the training set, we'll evaluate both the models, like what is the performance of the model, right? And again, we'll validate that on the validation set, that the performance that we saw on the training set, is it the same on the validation set, right? And here, based on the performance on the validation set, we'll select a final model, and then we'll use that model on the test data set, right? And there we'll evaluate the final model, and we'll evaluate the mean square error and R square for our final model. Okay, so I think, yeah, those were steps 4, 5, 6, 7, and 8 that I just described here. So, okay, this is just to show you our data set. So the first 5, 7, 4, 1 rows in our data set are for our training data set. And then the blue rows here you can see as our validation set, and the green rows as our test data set, right? Now I'll take you to our training data set. So here, this is our model one, where we are taking all the four variables, right? So we are training it on the 60% rows, all the four variables. And we can see here that our standard error is 4.5, and our multiple R, which is correlation, our R square, actually, which is the correlation between the predicted value and outcome variable. So 93% variance we can see, right? Now I'll take you to our model two, right? So as we removed, you can see we removed the temperature variable from here, and our variance has decreased from 93% to 80%, right? So our variance has decreased, and our correlation has decreased actually, right? So we can see a 80% variance. Our correlation has decreased. Our correlation was very high here, meaning that this data set is, with all the four variables, is giving us a higher, better prediction, right? So the standard error is 4.5 here. The error you can see has increased to 7.6 here, right? Now, just to validate this again, we are using the validation set. So this is the 20% of the data, and we can see the standard error here is 4.6. The correlation is 92.7. The variance is 92.7, the R square value, right? And this is in line with what we saw in our training data set, right, for model 1. Now, if I go to model 2 for the validation, again, it is coming to be 80%, which we saw for model 2 in our training data set also. So hence, we have reached a conclusion that our model 1 is more, has a higher correlation, has a less error. So it is a better model, right? As compared to model 2, where our error is increased, right? And our correlation has decreased, right? So hence we select the model 1. And now we will apply the model 1 on test data set, right? So this is our test data set. And again, you can see that our correlation has increased here. Our R square value is 92.4%, 0.92. And we can say that 92% of variance in outcome variable, 92.4% of variance in the outcome variable can be attributed to the predictor variables, right? So again, clearly our standard error is 4.6. And like how it was taught in our course that we should be calculating the mean square error to evaluate the performance. So here I've calculated the mean square error from two different methods. So one is the standard error, which was given to me by the Excel formula, right? So it was 4.6, and I could just square that, and it's giving me 21.7 as the mean square error, right? Standard error square. And here I've actually calculated the mean square error. How I've done that is, Excel gives us the residual values, which is nothing but the error when we subtract the output from here with our predicted output, right? So we are basically we are subtracting a predicted output from our actual output, which was there in our data set, right? So we are getting a minus 2.5 value, right? Which is the error. And when we square this, right? So square this error. So this is the value we get. And here in the mean squared formula, what we are doing is we are summing all these values, all the 1914 values that we have, right? We are summing that, and we are dividing it by the number 1914, 1914 rows to get our mean squared error uh, result. And this is matching our, automated whatever standard error was giving the I did a square. So these values are very close. So our mean square error value is 21.6. Our R square value is 0.92. And we can say that 92.4% of variance in outcome variable can be attributed to predictor variable. This is using our model where we are using all the four variables. When we reduce one variable, temperature, this variance decreases and our error increases. So that's why we are saying that model 1 is more accurate. And this is just to show you the approach that we followed. Thanks a lot. Please write to us if there are any questions.